This is Euclid Book 10, proposition number 109. And it says, if from a medial area a rational area be subtracted, there arise two other irrational straight lines, either a first apotome of a medial straight line, or a straight line which produces with a rational area a medial whole. For from the medial area BC, okay, now we got this BC right across here. That's this and this together. That's this one right here. Let the rational area BD be subtracted. Okay, we're going to subtract this area right here from all of this. Okay. I say that the side of the remainder EC, which is this area right here, becomes one of two irrational straight lines, either a first apotome of a medial straight line, or a straight line which produces with a rational area a medial whole. For let a rational straight line FG be set out. That's this line right across here. And let the areas be similarly applied. It follows then that FH is rational, okay, so this line right here is rational, and incommensurable with FG. This is incommensurable with this. While KF is rational, this is also a rational line, and it is commensurable with FG. Okay. Therefore, FH and FK, this line here and this line right here, are rational straight lines. They are only commensurable in square. This is by Euclid Book 10, proposition number 13. Therefore, KH is an apotome. That's an apotome. And FK has been annexed to it. This is by Euclid Book 10, proposition number 73. Now the square on HF, that's this one right here, is greater than the square on FK, which is this one right here, either by the square on a straight line commensurable with HF, or by the square on a straight line which is incommensurable with it. If then the square on HF is greater than the square on FK by a square on a straight line commensurable with HF, while the annex FK, this is the annex right here, it's from here to here, is commensurable in length with the rational straight line FG set out, KH suddenly becomes a second apotome. And that's by Euclid Book 10, third set of definitions, number 2. But FG is a rational line. So what we're going to do is we're going to make this rectangle. We've already established that KH is a second apotome. We've established that FG is a rational straight line. Now we're going to say that FG is an apotome. It actually becomes the first apotome of a medial straight line. Okay? Now, why do we have to say that about FG? Because what we're wanting to say, in essence, is that the side of LH, okay, this is LH right across here. Now we're going to say that the side of LH is a first apotome of a medial straight line. Well, what is the side of LH? Well, you can say, well, KH is a side of the LH, but we've already established that that's the second apotome. So if this is the second apotome, and this is the same length as this, these two lines here are second apotopes. Therefore, they would not be what we're looking for. So what are we looking for? We're looking for LK. LK is the side of LH, which is the first apotome of a medial straight line. That's what we're looking for, and that's by Euclid Book 10, proposition number 92. But if the square on FH is greater than the square on FK, if this is bigger than this, by the square on a straight line incommensurable with HF, while the annex FK, which is this, is commensurable with the rational straight line FG, when this is commensurable with this, KH suddenly becomes a fifth apotome. So this is not going to be a second anymore. This is going to be a fifth. And I'll write it right here. F-I-F-T-H. Now KH is a fifth apotome. So that's not what we're really looking for. Okay. Now we need the side on EC. Well, what is the side on EC? Well, EC, this area here, is equal to, let's see, I believe that that area is equal to this. This area is equal to this. Okay? So, how do we find the side on EC? We find the side over here. Okay, we've actually reshaped EC into LH. Okay. So, if this is a fifth apotome, then LK is the side we're looking for. And LK happens to be a straight line which produces with a rational area a medial hole. That's by Euclid Book 10, proposition number 95. And that is the whole proof. All right. I will tell you more in a future video, so I want you to stay tuned.